Hello, thanks for joining me again today. I'll be working on drakon render again. Let's switch to the code view. And here's the result of our session from yesterday. I can now show a fork like so. These V's indicate the presence of valent points. This is just for troubleshooting / debugging. In the white paper, it's clearly stated that valent points should not be rendered, but for the troubleshooting purposes, we can keep them in. There is a number of things that I wanted to do today. First of all, fork looks like so now. It's a dedicated data type. And it is showing valent points. Now, here in the data constructor of a fork, we see that both left and right side of the fork are diagram blocks, and they are, I believe, populated with something, with an action. But as you can see on the rendering, this still says V. So I have this in mind for today to be corrected, but before we do that, what I did realize is that we'll need a number of small corrections to the to this type, because now, a fork really can have a diagram block on the left and a diagram block on the right, but if we only allow just one diagram block, we cannot stack them together. So this is the wrong abstraction. What we ideally should have is list of diagram blocks in order to achieve structures like so. Maybe I can find it in the white paper. And this is where I believe the white paper is incorrect again. See, if we only had one element, like a word. If we only had one element to be placed inside the valent point, and that element was a letter, where would how would we stack multiple actions together? So in order to achieve structures like, for example, these two, these two actions are inside of a bigger word, and I believe this is a silhouette diagram word. So it needs to be a collection of blocks. But let's find a more suitable example where we have more than one block inside the left or right side of the question. Here. So we have a question here. On the left, we have 0 blocks, which is perfectly fine. The valent point is just not replaced with anything else. But on the right, we have a list of 2 diagram blocks. This is an action, and this, I'm not sure, comment or... Let's just take a look at the white paper. It's a comment. So in order to represent this as a data type, this right needs to be a list of diagram blocks and not just one diagram block. And this is one adjustment that we need to make. It's pretty easy to fix. Perfect. So if you watched the session yesterday, I had a bit of a problem getting the instance, the show instance to work for the fork block. I got it fixed off camera and it looks like so. Now, we have one thing addressed, so now we can chain multiple diagram blocks together in a fork. There's another problem though. If you look closely at the diagram block type, the diagram block can be a terminator or a skewer diagram block. So this is not, well, it is correct for this application, but the diagram block defined like this will not work in a fork, simply because you cannot place a terminator like this. A terminator would either cut off the entrance that the fork gives it, or it would cut off the exit that the fork gives it. Meaning, inside a fork, we can only use a skewer block, which means we need to tweak this a little bit. Skewer block. Okay, so now this should simplify our construction of the diagram to this. Oh, it will probably break at show. No, it won't. Cool, that's good. And it still works. That's lovely. Now the diagram block is fine. It will be used only at the very top level of diagram. That's fine. So I took some notes and I'm just crossing them off now. The list of skewers is done. Okay, now the last thing that I have in my notes for today is despite the fact that we have both left and right side populated in our fork. Let's call it a fork. We still display V, standing for valent point. So what we need to do is change this slightly. And in the show implementation of fork, okay, which we don't have, we should state that, maybe we do have it. We should have a data implementation for fork. Yeah, here. This is probably incorrect. Okay. Because what I would expect is show implementation here, and that's probably what we should do instead. So let's do this. So in the show implementation, yeah, because if we were to provide all that decision making and logic here, it would make this instance very bloated. So instead, let's push the implementation of show here to the closer to the fork data type. And here we can destructure the fork and say not headline, but fork log visual with text. And then here we can just use x show x. And that makes this implementation reasonably clean and easy to follow, and this implementation close to its source, meaning the data type. So I think this is a change for the better. Now, we still disregard whether the valent points are replaced with a list of skewer blocks or not. So this is what we should correct now. So fork block visual now should receive the entire fork. Because we should be able to reason about its contents. So now we don't really need this because it's going to be an integral part of the show implementation. Content strikes again. Here. Perfect. So now we can decide whether to inject a valent point or not. So to begin with, if null left, then v, else let's just say O. And if null, right, then O. So just for a test, let's make one of them empty. So here we should get a V, and here we should get an O. That wasn't what I expected. Oh. maybe. Not exactly what I had in mind. I must have deleted something by accident. Hmm. Oh yeah, perfect. So this proves our test to be fine. We do have elements here, but we don't have elements here. And so I'm pretty happy with this already. Okay, so these are populated. Now, the next logical step would be to try and render those lists of skewers. So let's check the time. We should be able to at least kick it off today. And you know what, let's do that after a quick break. I'm back now, so let's dive into the code. Okay, so we want to render the actual skewer blocks or collections of skewer blocks in place of these O's. Let's see how that goes. So to begin with, let's just cheat a little bit and pretend that the collection does not exist. Because this is already pretty messy. Let's just do show action. Show action. This is probably going to break our diagram. Let's only do it for the first one. Because, Okay, so action already comes with this connector shifted. Now let's leave this. Okay, the action is good. Now, I think we can shorten the length of the fork branch by 1. I believe this controls it here. And I believe this controls it here. Oh no, let's not do that. Let's only do it for valent points. Okay, so we'll need a helper function. That is fine, we can survive with this. And now we'll have to make some more room for this guy. So instead of this let's replace this 3 with 10 for now, just to make some room. That should give us enough room to fit the other block here. So where we have an O, we should do show action. And where we have a V, we should do this. And the new line only applies for V. All right. What happens if we... Oh, this is going straight to the new line. So we'll have to shift this. Or we'll have to shift all lines of action by an offset. So for now, let's just do an artificially made string. It's almost there. Overshot it a little bit, but this is where the action should start, and every row of this should be shifted. Okay, let's take a look at the time. Okay, so what I think would make sense is show does not really help much because it doesn't accept any arguments. But if we implemented provided our own type class show with offset, we could shift all lines by an offset. Let's see. Let's leave this comment in. So I'm going to need to resort to Google. Let's call it an ASCII show. And that will accept offset. I hope this is how it's done. Maybe we don't even need to define this. Okay, we can ignore these suggestions for now. They're just cosmetic. Let's just focus on this. So instead of providing an implementation of show, let's do ASCII show with offset. Oh, we can't do that. Oh. So it's okay. We can have both a show and an ASCII show. Or even FC. And here we have fill. It's something that's easy to see, like, say, 30 x. It doesn't have to be 30, it can be 5. So that ASCII show could be used. Oh, so ASCII show is not for a fork, it is for the action itself. Oh, sorry, it can stay there. But this does not have to be defined for a fork, but for a skewer block. I hope this works. So we need ASCII show action. Oh, sorry. Here we can just leave the V in place. Show action. Oh well. Let's just revert this back to O. Because it's just easier that way for now. Kick this out of here. Kick this out of here. Just to restore the previous status. And now we can do offset. And let's offset this by, say, 5. it just magically worked to have set it in the right place. But if we have done offset 3, A would be placed in the wrong position. Perfect, yeah. And everything would get shifted. Okay, let's check the time. I think we can do one more quick thing today. And that is to finish implementing ASCII show for action. Where every line is shifted. Let's see what action has right now. Visual block. Let's provide an offset here as well, so that it can be used both in show and in show ASCII. No, you know what? It's easier to move around if I, delegate this to a separate expression. Like so. Again here, that will signify a new line. And a new line again. This is going to cause a lot of compilation problems. Yeah, so in order to avoid that, what? That's fine. So the offset in all these should be 0. Should be quite simple to fix. Now, where were we? Right, excuse me for a minute. All right, back from a quick break. Now, where were we? I think we're supposed to use the new visual block function where we used to have just ASCII show foreign action. Sorry to be jumping around like this with the code. Okay, I think we're good here. With an offset, say 2. Let's see, 141. This looks correct. This looks correct. Visual block core also needs to be offset. So we're going to delete this, and the visual block core is also going to get an offset. You know what? I don't mind staying in the ASCII world for the time being, just to visualize the diagrams. We'll go back to SVG at some stage, I'm sure. So now, line number 1, line number 2, and line number 3. This is going to break some elements. Oops. But it's fine. Forward. let's use this offset here. I wonder if it suggests to reduce this function and remove the offset. No, it doesn't. But you know what? That's fair. Okay. It's all shifted minus this one. I wonder why. I must have played something incorrectly. Ah. Here. Okay. So it's not looking the prettiest, but this offset is going to become critical when placing items that are not on the main skewer, which is good. So for now, I think it's a good time to wrap this session up for today. Good progress today, and tomorrow I'm going to try and render everything we can see with an offset, including these parts here. Having said that, thank you very much for your attention today and for sticking with me. I hope this was enjoyable. And yeah, I'll see you next time. Have a great day. Bye.